Okay, so we're going to go through common factoring. And what they've done in a question like this is, it can be hard to see because they've written it where normally we would have a variable if we're working with a trinomial, maybe x. They've replaced it with what looks like another expression or another equation. This can be hard. So I'm not sure if you recall in grade 9 ever doing let statements. We're going to do a let statement. What that is it allows me to change my equation. It says let x plus 2 equal, and I'm just going to say the letter y. So in other words, what I'm going to do is I'm going to replace these brackets with the letter y, so it's a little easier for me to work with, okay? So what that means, I shouldn't use y actually because I have y out here. Let's say z. Let y equal z. So we get y is equal to 5z squared plus 7z plus 12. Okay? Now, technically this is like a trinomial now. I might be able to actually do factoring when a is a value other than 1. And we could technically check this out. I think they're trying to get 2 common factoring in this question, but let's just double check to see if we can common factor. Now, do you guys do decomposition when you do it? 2 numbers that multiply to a and c?
Yeah, sometimes.
Yeah? Did you ever do the one where you find the factors of the first and the factors of the second?
Yeah, that's the one I do.
That's the one you do? So let's go with that. Let's see if this will work. So we're going to look for the factors of the first, which are 1 and 5, and factors of 12, which are 1, 12, 2 and 6, and 3 and 4. And we need them to add up to our middle term. And again, actually, this should be squared because if you recall, this bracket was technically squared there, right? So let's go through this column real quickly here. 1 by 1 and 5 by 12 is 60 and 1. Not 60, we needed to add to 7. 60 and 1 won't really add up to our value of 7. Yeah. And then we always test across 12 and 5. Well, actually, that works out. We can get 12 and 5 if the 5 is negative. Okay, but if this was negative 1, what is 12 times negative 1?
Negative 12.
Yeah, and is this negative 12?
No.
No, so that actually doesn't work. Even though it was a combination, because our products won't work, we can't use that. So that means this first set isn't a pairing for us. Okay, let's try the next. 2 and 1 and 6 and 5. That gives us 30 and 2. Any combination of that makes 7?
No.
No. Okay, let's try the other. 5 and 2 and 6 and 1. That's going to give us 10 and 6. Any combination there work?
No.
No. Okay. So second pairing didn't work. And finally, 1 and 3, 5 and 4, that's 20 and 3. Do they make 7?
No.
No. 5 and 3 and 4 and 1, that's 15 and 4. Any of these combinations work?
No.
No, so nothing worked here. We were unable to factor trinomially. Now, technically, there'd be something called quadratic formula, which we'll get into later. But I think really the gist of this, like we wrote at the beginning, is common factoring. So now when I look at this, specifically the first 2 terms, and I'm going to rewrite it again all in black. Y equals 5z squared plus 7z plus 12. Let's take a look here. In the first 2 terms, can you find a common factor in the first 2 terms?
Z.
Z, yeah, we can take z out. So of just the first 2 terms, we're going to divide both by z. Okay, so y is equal to z. What would this become?
5 squared.
5, actually it would still just be z because z squared divided by z to the power of 1, you subtract the 2 exponents, so we kind of z to the power of 1. And what would this become? 7z divided by z.
7.
Yeah, that's right. Does anything happen to this 12?
No.
No, we just leave it on the outside. Okay, and I know this is a stretch because we kind of got off track with our trinomial factoring. Okay, but here's the idea. If you recall, we wrote at the beginning let z equal x plus 2, I believe, right?
Yeah.
So z, in this case, is a little different than it should be. So what we're going to need to do is we're going to need to replace the 2 z's in the equation with this here. Okay? So in that case, we get y is equal to, I'll replace this z with, I'm going to do it in blue, x plus 2. Okay? Bracket 5. This z needs to be replaced with x plus 2 And then we rewrite the rest. Plus 7 plus 12. This is a pretty ugly example because this simplified form doesn't really help for our clarification. It's very complex in here. But the idea is sometimes we represent these. I feel like, did I steal a specific example? Oh, I changed the number, that's why. We change these to help us do a set of factoring. So this is a factored type form, but a bit convoluted. And I'll rewrite it all again in black. So it looks like it's x plus 2, 5, x plus 2, plus 7, plus 12. Okay? Now, that would be an example of common factor.